I naught will be equals to V minus E by. So we have this similar type of equation we have already seen in the previous step down chopper. So this you will get this, and at t equals to t of I naught will be equals to I max. So you have to state that I naught will be at I max during the off period. So when t is off, so I naught will be equals to I max, and we can find out that I max will be V minus E. So t will be equals to t off. So it will be minimum current, I minimum. So the same equations are modified here. So during the interval, chopper is on, the voltage equation is given by, when the chopper is on, then the voltage equation will be LDI naught, because it's a regenerative action is taking place. So LDI naught divided by dt, so RI naught plus E. So in this case, so if you redefine the time origins at t equals to 0, then I naught will be I max. So during this is a stand, so it will, when the chopper is on, so at this point the chopper will start conducting. So that's what is given. So I naught will be I max. The solution for the state initial conditions will be I naught will be I max. The same equations are used. So in this case, so a minimum current will be equals to I max. So same equation has been modified when at t equals to t on, and I naught t will be equals to a minimum current. So class B chopper. Okay, in class B chopper it's a combination of a class A and class B chopper. It's like combinations. Both it's working on the first quadrant as well as the second quadrant. So class C is a combination of these two choppers, class A and class B choppers. And if you see, it's working in the first quadrant and the second quadrant. So it's combinations, and first quadrant CH1 will own, that chopper 1 will be on during the in the first quadrant, and it's on in D2, or D2 will conduct. So these two will conduct in this. And for second quadrant, the chopper CH2 will be on, or D1 will conduct. And when the chopper 1 is on, the load current is positive. So in this, load current is positive. When chopper 1 is on, load current is positive. If you see here, when it's in first quadrant, both the voltage and current will be positive. But when it operates in the second quadrant, the load current will be negative. So with this diagram, with this quadrant diagram, you can see this, the current will be negative. But in this case, when it operates in the first quadrant, it will be positive. So load current is positive, the output voltage is equals to V, and the load receives the power from the source. So the load will receive the power. In this case, when this operates, the load will receive the power from the source. In this case, when this chopper CH1 is operating. And when the CH1 is off, energy stored in the inductor forces the current to flow through the diode D2. So when it is off, it will forces the current to flow through this diode D2. So whatever energy is stored during the on period of this chopper, it will try to flow. So at this period, D2 will start conducting. So through the diode D2, and the output voltage is equals to 0. So current will continue to flow in a positive direction in this case, because it's operating in the first quadrant. So when the chopper CS2 is triggered, the voltage E forces the current to flow in opposite direction through L and CS2. So when it is triggered, when the chopper CS2 is triggered, when this is conducting, so it will try to flow in the opposite direction. The output voltage is equals to 0 in this case. So on turning off CS2, the energy stored, whatever energy is stored in the inductive drives the current through diode D1 and the supply. So output voltage is V, the initial current becomes negative. So when the initial current will become, power will flow from load to source. So in this case, power will not flow from the source to load. In this case, it will flow from load to source. So average output voltage is positive, and the output current can take both positive and negative value in this case. So in this, what is happening is that it can take both the value, because it's operating in the first quadrant as well as in second quadrant. Chopper CH1 and CS2 should not be turned on simultaneously. It should not be turned on simultaneously, as it would result in a short circuiting the supply. So both the CS1 and turn on simultaneously. So chopper C, class C chopper can be used both for DC motor control and regenerative braking of the DC motor. So it can be used for the control of the DC motor. You know that class A chopper is used for the DC, means like for DC motor control, and class B is used for regenerative braking of the DC motor. So it can be used for both the DC motor control as well as the regenerative braking of the DC motor. And it can be used as a step up or step down chopper. So it is step class A chopper is step up, step down chopper, and class B is a step up chopper. So it can be used for both the step up and step down chopper. So it means that class C chopper is better. Means if you try to compare with this, it can be used for both the step up and step down. So this is given how does it works when this is the conditions, when this initial, when the D1 is conducting. So at this point, so when it's triggered, the chopper CH1 is on, and when CH1 is off at this point, then the D2 will conduct. So similarly, then CH2 will conduct. So this is the output voltage. So output voltage will be from this point to this when the CH1 is operating. So based on this, means the same thing will continue. And this is the pulses given, gate current IG1 and IG2. These are the gate current pulses given to the thyristors or SCRs. So this is the output current. Output current, whether it means like it's going from D2 to this up to this point to the maximum maximum. Then when this chopper is conducting at this point, it will reach to maximum. Then when the chopper CH1 is off, then D2 will start conducting. Now class D chopper. In class D chopper, if you see here, it's operating in the first and fourth quadrant. It means that it's a combinations. So similar to the class C chopper, class D is in a 2-quadrant type of chopper. In class C chopper, first quadrant and second quadrant, and class D chopper, first and fourth quadrant. So when both the CH1 and CH2 are triggered simultaneously, output voltage will be equals to. So if you try to trigger both the chopper 1 and chopper 2 simultaneously, output voltage will be V naught will be equals to V source voltage, and the output current flows through the load. So if you try to trigger this simultaneously, and the chopper 1 and chopper 2 are turned off, the load current continues to flow in the same direction through the load D1 and D2. So it will try to flow from the load D1 and D2 in this case. And due to the energy, so whatever when the chopper is on, what at that period of time, that energy will be stored in the inductor. So output voltage at this time, when it is off, then the output voltage V naught will be equals to minus V. So if you see in this case, the output in the fourth quadrant, the output voltage will be negative. Just try to focus on this fourth quadrant, right? So at this period, at the fourth quadrant, the current is positive, but if you see the voltage is negative. So the average load voltage is positive if chopper its on time is more than the off time. So if you try to see here, during the on time, okay, if the on time of the chopper is more, then the average load voltage will be positive. I told you in the beginning of this class that chopper will depend on the TRC, time ratio control, or the on period and off period of the chopper. How long the switch is on. So we are just talking about the duty cycle. Duty cycle is T on divided by total time period T. So if you try to focus on the PCM, pulse code modulation, okay, modulating the pulse. So if you keep the time period constant, and if you try to manage with the T on and T off, but there are certain disadvantages also. If you try to prolong this T on time for longer period of time, what is the output? What is the effect on the output? So that also you have to keep on mind. But now what you have to know is that how long is that this chopper operating, means it's kept on. So we have to keep in your mind that the turning on time period will depend, the output will depend on the turning on period time. So if you see here, the sentence itself, the average load voltage is positive if the chopper on time is more than the off time. It means that the on time is more than the off time if the total time period is T. Okay. If the on time is 2/3 of the T, then the average load period will be more than that off. Means the average load voltage will be positive. So average output voltage becomes negative if the T on is less than the T off. So the second sentence is clearly shows that if the T on period is less than the T off period, let's say T off is 2/3 of the total time period T, then the average output voltage will be negative. So the direction of the load current is always positive. If you see, the direction of the load current will always positive because it's working on the first and fourth quadrant. So the current is always positive in this. But if it is in the second quadrant, it can be a positive or negative. This current is negative in this side. So this is a positive current. So if you see here, the direction of the load current will be always positive, but the load voltage can be positive or it can be negative. If you see, the voltage is positive as well as negative. So load voltage can be positive or it can be negative. So it depends on the turning on period of the SCR. So if you see the waveform of this class D chopper, so first two waveform IG1 and IG2, these are the pulsed triggered to the chopper 1 and chopper 2. Now this chopper 1 and chopper 2, chopper 1 and chopper 2 are triggered simultaneously. If you see here, it is triggering CH1 and CH2 are triggered together. But if you see in class C type of chopper, it is not triggered simultaneously. So if you see the difference on these two, and the output current, if you see the output current during this period, both the chopper CH1, chopper 1 and chopper 2 are on at this period because you are triggering the SCR. It means you are triggering the SCR at the same time. Both the chopper 1 and chopper 2 are triggers at the same time. But in class C chopper, it is not triggered at simultaneously at the same time. So please note down this difference. It's quite important to know the similarity between the different type of chopper. If you do not look carefully on the waveform of this type of choppers, it's quite means like important for you to understand the waveform. So if you see here, the total T on time, this is the total output voltage, average output voltage. Average output voltage is taken when both the chopper CH1 and CH2 is on, and this is the period when the diode D1 and it's off period. So diode D1 and D2 is conducting. This is the so we can find out the average output voltage. So average output voltage will depend on the on period and off period. So in this case, on period is more than that of off period. So similarly, this is positive, right? Average voltage is positive. If you see in this diagram, the on period is less than that of off period. I told you in the beginning that in this waveform, the on period is less than that of off period because both the thyristors means in chopper 1 as well as in chopper 2, the conduction period is less than that of the off period. So in this, if you see the average output means load current, it will always be positive. Okay, output current will always be positive because it's working on the first and the fourth quadrant. So CH1, chopper 1 and chopper 2 is conducting. This is so if you see D1 and D2 conduction period is more than the chopper 1 and chopper 2 conduction period. So the off period is more than that of on period. That's why the average output voltage is negative. If you take the average output voltage will be negative. That's why the sentence that the sentence which was given in the previous slide is that the voltage can be positive or negative, but the current will always be positive. So this is another type of chopper which is known as a class E chopper. If you see here, there are 4 SCRs are used: CH1, CH2, CH3 and CH4. Okay, before going to class E chopper, do you have any doubt till now? I'm just giving you the, okay, you can just own your mind, okay, based on, so everybody please don't own together, okay. So if you have some doubts, okay, you can just ask, you can just discuss. Because what I feel is that till now, okay, whenever we are teaching online, okay, it's same like a one-way type of thing. Sometimes you may not understand some of the things, right? So just to make sure that whether you, if you do not understand, okay, whatever I teach here, that I feel that is not like, at least if you get something, let's say around 40 to 50%, that is more than enough. I feel that. But other percentage, like remaining, if you go through the textbook, at least you'll understand that the thing. But if you do not understand whatever I'm delivering on the online session, okay, it might not be helpful for you. So do you have any doubt till now on this chopper? Dichin also. Dichin, can you hear me?
Yes, sir.
So so can you, so are you able to understand whatever I'm delivering on online session?
Not that much, sir.
I know, okay, we cannot have or like the same like a one-to-one communication like as in a normal formal class, okay. But
Sir, one doubt, sir.
yes,
One doubt.
what's the doubt?
Sir, this regarding last time at almost beginning, sir. This sir talk about this chopper, no, sir. In chopper
Yes,
circuit, about the use of capacitor. Sir mentioned that the use of capacitor is to increase the outputs, no, sir. Regarding the output, sir mentioned about this one's a function, the function of capacitor. But sir, in chopper circuit, the source is being used as a DC source, no, sir. Sir, this,
yes,
but sir, actually this in capacitor this DC source does not pass through, no, sir, because the capacitor act as a blocking capacitor, no, sir.
okay. I'll okay. I understand your problem. Okay. Now any circuit, okay, any electronic circuit, there will be a generation of harmonics. Okay. Any electronic circuit, there will be a generation of harmonics. So this generation of harmonics means it's an unwanted signal, right? It's a disturbance. Let's say in a receiver, right? When you tune on a receiver, okay, you may not hear the clear voice, but this receiver is operating in a DC, right? There might be an unwanted signal interference on this particular thing. So those on the generation of the harmonics can be within from a component. It can be by the external force, or it can be a generation of harmonics can be within the component. When the component is operating, right? Let's say a resistor or an inductor, or let's say a capacitor. Capacitor is there. So there will be a generation of harmonics within a system. So this system means this is an unwanted signal, right? So these unwanted signals needs to be removed from the system. That's why the capacitors are, you must be thinking that it's just a DC, right? You're converting a DC, a fixed DC to a variable DC. And how come that capacitors are working on this? Out here, I'm talking about is a disturbances, the generation of the harmonics within a component. So there will be a disturbances. I have given you the example of a receiver. A receiver means you are not receiving a pure signal. There might be some disturbance. If you when you are tuning a radio receiver, if you try to switch on and off of power in a house, then there will be a disturbances on the sound will be there in a receiver. So what is this? Actually, it's an unwanted signal, right? Those signals are unwanted signal. So similar, that is the external force actually. But The other thing is it can generate harmonics within a component, within a system also. So just to remove those components, when you are converting from one form to another, there will be so many components involved. There are so many processes involved when you convert from one form to another. Means like one voltage label to another voltage label. So you're not just cutting, and it means like there are some components involved on it. So there will be a generation of the harmonics. So is it clear to you?
Yes, sir. But
Okay.
sir, this one it will not, sir. In other cases, this DC this capacitor act as this blocking state, no sir. But right now here, it's for removing this harmonics, no sir.
Yeah, well, in case of let's say in case of a rectifier, okay, you're converting AC into DC, right? So you do not get a pure DC at the output. So what you are using pulsating DC, right? So your the pulsating waves will be there. To remove this unwanted AC, we unwanted signal means like we use a capacitor. In that case,
Yes, sir.
so if you see here, let's say a class C chopper, right? So we are using an inductor and a resistor. So inductor will store the energy in this case. So anything, okay, any electronics devices, most of the electronics devices, if you just open and see, at least you will see a capacitor, because your requirement, there might be some disturbances or some harmonics generated within. So that is the case. I don't know if you have understood or still you have a doubt.
Sir, again, this one. So last time there are two methods, no sir. One is
Yes,
pulse width modulation and frequency control modulation, no sir.
yes, yes.
Sir, in this pulse width modulation, it can be sir, possibility of multiple pulse width modulation also.
Pulse means it's a pulse, right? So in this pulse width modulation, what it's doing is that the t time frame t is kept as constant. Means total time period is kept as constant, and we are playing with the t on and t off. The other one is frequency modulation. In frequency will depend on the total time period, right?
Yes.
So t equals to 1 by f. So the total means that it will depend on the, we are playing with the time period is t is as fixed, means pulse width modulating is the modulation, right? So we are mixing the carrier signal, the Morton signal with the carrier signal. So first you have to understand what is modulation, right? Means you're playing with the total time period t. So t on time and t off time, we can manage this. In this also, let's, okay, I just showed you this. Just see here. So in this waveform, right, where total time period t is kept as constant, but the t on period and the average output voltage will depend on this t on and t off period. So pulse width modulation, it can be a multiple pulse also. Pulse can be a multiple pulse, and it can be a single pulse. One pulse, two pulse, or multiple pulse. It's a pulse means it's just a, what do you say? You are giving a fixed pulses, and with that fixed pulses, we are just playing with the TRC, time ratio controller. Is it okay? Or
Okay, sir. Because last time this multiple pulse means I was wondering, sir, in a single pulse it's divided into many, so how this it is been managed?
yes, sir. Yes, it means I understand you, because you might mean you have not studied this communication, okay? But if you have some communication background, then it would be quite easier for you to understand this term. Because when you talk about this, okay, there is two things. One is frequency modulation and frequency modulation technique, and time division, division modulations. These are the two things. We're talking about the time, and other one is the frequency. So in frequency division multiplexing, we are dividing the frequency. in time division multiplexing, we are dividing the time. So each, let's say in terms of communication point of view, each customer is allocated with a particular time. But in case of a frequency division multiplexing, what we're doing is that we're dividing the frequency. So each customer will be allocated a particular frequency. Even in the broadcasting media, okay, they are given a band, which is known as, they are giving a band of 0, let's say 5 to 10 megahertz. So maybe BBS2 can broadcast their program at from 5 megahertz to 10 megahertz. So it means that there is a auction, okay, going on in a government, intergovernment level also, that there will be a 3G auctions. So all these 3G, 4G spectrums, okay, we call as a spectrum. Okay, these are the GSM network, Global System for Mobile Communications. So I'm just trying to give you some background of that communication so that you will understand this. So there is a frequency modulations, amplitude modulations techniques. So based on this, there is a, and most of the time they use this pulse width modulation technique also. So pulse width modulation technique is one of the most commonly used techniques. And in some of the metropolitan cities, they are using CDMA, code division multiple access. I don't know how many of you have heard this CDMA, but what we have in our country now is all GSM network, Global System for Mobile Communication. I know some of you have used this GSM module, right? I think CR has done during last what the innovation day, he was using a GSM module. So means that he is able to communicate with the SIM. Means that is how, means it's a GSM module, global system. Full form of GSM is a global system for mobile communications. So what we are doing is now we are using a GSM technique, and most of the metropolitan cities where the population is quite high, they are using this CDMA technique or division multiplex, because when the customers keeps on increasing, you're given a certain bandwidth, a certain spectrum, and if that spectrum is not sufficient for the customer, individual customer, I know beyond, if it goes beyond the certain numbers, our systems will collapse. That's why even if I don't know how many of you have read, okay, that Bhutan Telecom and Transcell is not giving a free. They are still working on how to give some subsidies to the students, because now if they give free internet facilities to all the population of Bhutan, the system will not support them. Because if 7 lakhs populations started using the internet facility at once, then the whole system will collapse. So that is the problem actually. I don't know how many of you have remember last time, it was a few years back there when there was an earthquake. You were not even able some means you are not able to make a call during that time, because there are certain things. I mean, if the subscribers goes beyond certain limit, then the whole system will collapse. Because of that, Bhutan Telecom has built another backup system in Bumthang. Now, if the system in Thimphu is collapsed, if it does not working, there is a backup systems in Bumthang. So they are going to host from that. I mean, they are going to start from the backup system from Bumthang. That's the same thing happening with the backup systems, like fiber optic cables, which is from Phinchiling with international fiber. Means like these are some of the gateways like Phinchiling and Gelifu, and Bhutan is trying to get another gateway from Bangladesh through Samjongkar. So if we have these 3 gateways now, then our internet speeds might go up. But now because it's just a bottleneck, right? We try to, when the subscriber gives up, if you try to increase the speed, if your input is less, then how can you expect the output more? That same thing happening. It's just a bottleneck. We just have these 2 stuff. Of course, we have from Gelifu and some Phinchiling, but it's from the same route. So that is what is happening now. No, just to understand with this, okay, I'm just giving you some background of the communication system, and to be implemented on this choppers or whatever you understand. So we are talking about the pulse code modulations or the frequency division multiplexing or TDM time division multiplexing. So that is what you need to understand. Okay.
Okay, sir. Thank you.
So others, are you okay with? I know I was just going through your assignment. Okay, I know you have submitted. Some of you have a problem. I don't know whether you have a problem uploading or some of you have sent in the mail. Okay, from next time, please try to use as far as possible. Please try to use the VLE. I know you might have a problem uploading in a VLE. Okay, or you are trying to send in the mail. Of course, you can send in the mail, no problem. But try to use VLE because the VLE. What I'm thinking is that maybe by next week or yeah, I'll give you the time that we might have MCQ type of online test. The test will be purely MCQ, multiple choice. So you will be allocated a certain time during means my period. So you have to complete this MCQ. I know it may not be fair, but just to check to go with the new system, okay, let's try to do it once. MCQ type of question. It will not be complicated one, but at least around 10 to 20 questions, MC multiple type of questions. Because in all around the world, okay, they are using similar type of, even we can give you the descriptive type of question answers type, but I feel that it will be difficult for you to type in a mobile phone. I know 90% of you are using a mobile phone, so I feel that MCQ will be much more easier. Is it, or you want to have a descriptive type?
So MCQ only, no, sir.
MCQ is
sir.
good. Okay, so everyone is with the MCQ, right? Multiple choice. Okay, I think I'll stop here. Okay, if I go, I know I can finish the whole of this. Okay, but go through whatever we have done till now. Okay, and if you have problem, we'll discuss. From what I'm thinking from next time, at least I'll teach you around 40 to 45 minutes. Around 15 minutes, we'll just discuss on the related topics, whatever we teach on that particular day, so that we can clarify. I know most of you might be having the problem with understanding. If you, from my side, if you get at least 40% of whatever I teach it here, that will be more than enough. What I see, because the online system, some of you may not have, might not hear the voice properly, or might be difficult for you. But please try to come attend all the online classes. Today also only 25 of you are there, out of I think 27 or 28. So please inform your friend. I think before I go, I think I'll take the attendance. How do you find in other modules?
Sir, feeling difficult, sir, because we are getting eye problem, no, sir. Always using electronic things, no, sir, because after this classes, then we have to assignment, no, sir, continue assignment, sir, and we are getting eye problem and headache, sir.
I know that
Not only assignments, sir. There are notes to copy also, no, sir. Oral teaching slide test, guys.
Yes, sir, completely packed, sir. We have to sometimes stay till 1, sir, time 1 or 2, sir, doing assignments, sir.
Sir, पेशेंट the time ram mito sir. Assignment da ancham chi bede ko sir.
Now I think we have already done 2 assignments. Okay, I think it's okay for now. I'll not give you the assignment. Okay, don't worry. we are already done with the 2 assignments. So I think for me it's okay.
This, sir, some assignment which are related to numericals are feeling a little bit tough, no, sir, because learning through slide we are difficult to grab the knowledge, no, sir. And when we have to write in A4 size paper, then do like this, feeling very difficult, sir, like machine and all.
I know there will be a problem. Okay, but for I don't know, but maybe it depends on the module tutor. Okay, for in my module in Power Electronics, now numerical problem, I'll give you the problem. Okay, but I'll not ask you to submit the assignment. But please do that numerical sincerely. You don't have to. You do it in a paper. Okay, so that it will be easier for you.
Okay.
Is it okay?
Okay.
네. 성화 시간이 빼시다는 얘기할 수 있지. Time chance consider the watching service. Let's see.
Okay, then what I'll do is I'll take all your feedback. Okay, feedback, and when we have a like online discussion, means like meeting with the TA. Okay, we need to talk with the TA and all that is. So even I feel that the number of periods, okay, we are we are continuously from 8 to sometime till 1, 2, 2, 3. Okay. So even I raised this once. Okay, if we have at least two module, two, 1 or 2 sessions, at maximum 3 sessions in a day. Is it, or how much do you want? How many
At the
sessions?
max 2 module, it will
Maximum two,
be
sir.
Two
at the max.
module यो चाहिँ छ notes चाहिँ
Sir,
चाहिँ
two
up to
period
date
of
जान्छ
three.
नि sir.
त्यसले चाहिँ 2 जिम्बा चाहिँ टिटिमी सर 2 or at the max 3 am चाहिँ max 3 बेरा सर 2
Maximum 3 sessions.
CST are following 2 and 3, sir.
then
At the max 3.
Sir, afternoon
Okay.
classes mengo zoom do sir. Afternoon na ji nando me sir. Net problem
And
ji me.
in case of my module, okay, that afternoon class which I have told to 2:30 to 3:30, I think we'll do away with that, right? So we'll have 3 modules for now. So I'll talk with this, your feedback with the TA, okay, whatever feedback, because it has to be uniform for all the department, right? So I'll talk with the DA and I'll give you the, even okay, with the help of the CR, okay, can you write the feedback, whatever feedback we have discussed now, to give a copy to me also and write this feedback to DA also, so that it will be easier when I talk to the DA also, because the feedback is already sent to DA also, right? So Karma Lodi, can you please coordinate and write this feedback? Is it okay?
Okay sir. Okay.
So whatever feedback, so that it will be easier for to when you discuss with the dean, right? DA, then I'll supplement on that also. So whatever the feedback given from the student side, okay, I'll talk with all this. Whatever you're telling, I can understand. Okay, even when we do it from the laptop, okay, it will be difficult. Forget about mobile phone; it's quite easy, small, right? We have to, the eye will be, will have a problem with the eye. So maybe at the end of the day, you might be having with the eye pain, or when you continuously look in your smartphone. So let's see, okay. And please, Karmaludi, can you just elaborate?
Okay sir.
Okay. So with this, I think I'll stop here. So we'll continue tomorrow. Okay.
Sir, Kumar Chitri is not able to join for today's class because there is no electricity at his place, sir.
Kagilo?
Kumar Chitri, sir. I received
Kumar
a call
here?
from him. Yes, sir.
Okay. So if you have this type of problem, okay. So if you can just inform so that it will be easier for me when I take
Yes,
the
sir.
Okay, thank you. Kumar Imo? Okay. Okay.
Thank you, sir.